Okay, so that's the last problem for the chapter statics about truss. And you know what? I will mix sections and um, joint and joint method. Okay, so the force P1, this one, it's equal to 10 kilonewton, and P2, it's equal to 2 kilonewton, 8 kilonewton. I should the same. I pick the same in the book. Okay. And the question is, what are the forces in each member? All of them. Okay. First, I want to show you something. We are in trouble at A and B and G because that's two-pin connection, so that's 4 unknowns total. So we cannot solve for all the unknown there. Eventually, we can solve for a axe using the moment about G, G axe using the moment about A. We can do that, but we will never be able to solve for GY and a Y by using all the truss as a free body diagram. Let's look at zero forces member. Long time we didn't speak about zero forces member. Are there any zero forces member? That will make our work easier. Look at the point joint C. At the joint C, we have 3 members, and 2 of them are collinear. So it means that this one is a zero force member. So we do not need to include this one in the free body diagram. I want to show you something because in your online quiz, I asked you to find this one. So there's a very simple way to find this one. We cannot use the joint method because if we do with these joints, we have 1, 2, 3, 4 unknown. If we do with these joints, we have 1, 2, 3, 4 unknown. So we cannot use the joint method with just one equation, one free diagrams. But if we cut here and we keep the right side, so the free body diagram will be this. We cannot do it with the left side because of the left side there's like 4 unknowns left on the left plus those 3 unknowns. But if we use the right side, what we have is something like that. We have a force that we know of 8 kilonewton, and we have 1, 2, 3 unknown. So make it a little bit stronger. And if we look at this on Y, the only force that we have unknown on Y is this one, B, E. This one is F, E, and this one is B, C. And so let's add that this triangle there, this one there is 2, 2 and 2. So this is 2 and this is 2, so it's 45 degrees. So what we can write the equation sum of the force on Y is equal to 0. And we have minus BE. So this is cosine 45 degrees, minus 8, it's equal to 0. So BE, it's equal to minus 8 divided by cosine 45 degrees. So BE, it's equal to minus, the minus means that it's in compression, and 8 divided by cosine 45, it's 11.3. Minus 11.3 kilonewton. Okay, so we have this one, and now we have this one. This is the BE equal 11.3 kilonewton. What can we do? Let's use the same free body diagram. So we can use the point B to solve for FE, and we can use the point E to solve for BC, right? So we are, look, I like to do that. We just get our truss there. Okay, so let's do, if you do the moment about E, so that's 2, this distance is 2, but we need also the total distance from B to this distance there, that is 3 meters inside, and this distance there is 2. Okay, so let's do sum of the moment about E. It's equal to 0. So we have this one. So we have 8 times this distance. Oh, I forget to write this distance. So that's 1. So 8 times 1. And this one turn in the negative directions. And the only 4 that we have left is BC. So, and it's plus, no, it's minus too. So BC is rotating in the negative directions. So minus BC time the vertical distance, that is 2, it's equal to 0. So BC is equal to minus 4 kilonewton. Oh, I forgot to write. So it's compression. This one also is compression. So let's call that. That's BC. Yeah, I didn't write F, BC, F, BE. But I could have. Let's do the moment about B. Also, we have B. Which one we found? BC. So we found this one. Okay. Moment about B. So this one. So we have the 8 that is rotating in the negative direction, but this time is time 3, minus 8 times 3, and FE is going in the positive direction. So plus FE, we cannot have the 3 of them in compression. FE, this one time 2 is equal to 0. So FE is equal to 8 times 3 divided by 2, so 4 times 3, so it's equal to 12 kilonewton. And this one is in tension. Okay, so we have this one. Let's remove my cut because we don't need it anymore. Okay, so maybe now we can use the joint method. Oh my god, that's my previous problem. I'm lost. This one. Okay, we can use the joint method at C. So if we do at C, so if this one is in tension, if BC, so that one is BC equal 1.3 in compression. This one is also, so it's CD 11.3 in compression. So CD is equal to 11.3 kilonewton. Let's put a minus just to say that it's a compression. It's not because it's a minus that it's a compression, it's because I guess that it was a tension, so my positive direction is tension. So CD is equal to minus 1.3 kilonewton, is called 1.3 kilonewton in compression. We missed this one. Let's solve this one. Let's do the joint D. Now we come back on the method of joint. So we have the joint D. So that's my joint D. We have the 8 kilonewton going down. This one is compression. Oh my god, we are on the joint. So we know it's compression. So it means that the joint is pushing on the member. So the member is pushing on the point D, and that's 11.3. And this one will be up. Has to go up. That's ED. And the slope, we have 1 and 2. 1 and 2. So this is the square root of 5. Okay. So if we do sum of the force on y, it's equal to 0. We can use either one, x or y. But if we did a mistake at 11.3, if you use x, we will reproduce a mistake there. If you use y, we don't reproduce the mistake. So sum of the force on y equals 0. So we have ED times 2 divided by square root of 5 minus 8, it's equal to 0. So ED, it's equal to 4 square root of 5. 8 divided by 2. So 4 square root of 5, it's 8.94 in tension. Here we go. So we have this one. Okay, so we know this one, we know this one, we know this one. We are everything to the right. At B, we can do an analysis of a joint. And after that, we will know BF and we can do a last joint at F. So let's do my joint there. I need to do my joint B first. I don't have a choice because here I still have 3 unknown. So joint B. Okay, so that's my joint B. I will have forces everywhere. So that's my joint B. What I know it is 10 kilonewton. This one is compression, so compression is pushing on the joint, and it's 11.3. This one in BE, we find 11.3 in compression, so 11.3, and we know that the angle is 45. Okay, and we have force at B, so it should be positive, and this one should be to the right to compensate. Everything is going down and left, so we need some forces up and right. So AB and BF. It's a joint, so joints mean we just have force on X and force on Y available. Either one will work. So let's do sum of the forces on X. It's equal to 0. We have AB minus 11.3 minus 11.3 cosine 45 degrees. It's equal to 0. So we have AB that is equal to, and it would be plus 11.3 plus 11.3 cosine 45 is 19.3. Is it BE? 11.5. BC. Just try to see. Oh, okay, sorry. BC there is not 11.3. BC there. I missed that. Oh, and my BC is 4 in compression. Okay, this one is 4. I knew there was not the right answer. So minus 4 minus 11.3 cosine. So 4 minus 11.3 cosine 45, and that's 4. What did I write? Oh, that should be 8. 12. 4 plus 11.3, sorry, cosine 45. 12. So it's 12 kilonewton in tension. Oops. Well, we got this one. And if we do joint cylinder joint B, but sum of the forces on Y, it's equal to 0. So we have BF minus 10 minus 11.3 cosine 45, it's equal to 0. And it's for the 11.3 cosine 45, it's always the same. 8. So BF, it's equal to 18 kilonewton, and it's in tension too. We're almost there. Okay, so we find BF. So now we can do the final dot F to find the last one. We can also go at A. Oh no, we cannot go at A because we cannot solve for AX, AY, and this one. We need to go at F. So we need to do the joint F. Okay, so that's my joint F. Okay. We have 40 that we know. So BF, oops. BF is in tension, so it's pulling. Oops. I always do blue. My computer is slow. BF 18. F, what is this one? FE. How much do we find for FE? 12 in tension. So 12 in tension for Fe. So 12 in tension. BF, it was tension too. Yes, 12. And the four that we don't know, we have this one. That is Fa. And this one, that is F. Oh, this one needs to go up. Can put it this. And Fg is easier to guess right, left, up, down with the join method. And Fa, it's 1, 2, and square root of 5 triangles. Okay, so let's do the force on Y first, because on X we have 2 unknown. So let's do the first on X. Sum of the force on X is equal to 0. So we have Fa times, so on X it's 1 divided by square root of 5 plus 12. Oh yeah, not X, sorry, Y first. Oops. Sum of the force on Y first is equal to 0. So Fa times 2 divided by square root of 5 minus 18 is equal to 0. So Fa is equal to 9 square root of 5. It's 20.12, 20.1. And it's tension. And the last equation, the force on X. So we find Fa. Boom. And the last equation, so we use these diagrams, fluid diagrams. So sum of the forces on X is equal to 0. So we have minus Fg, we have plus Fa. This one, this time is time 1 divided by square root of 5. Oh, I didn't put my axes, X and Y. Don't forget your axes. Okay, for this one too, X and Y. Okay, so Fa times 1 divided by square root of 5 and the plus 12. It's equal to 0. So Fg is equal to 12 plus the 20.1 times 1 divided by square root of 5, and it's equal to, is it too much? Oh, 20.1 divided by square root of 5 plus 12. 20, I have 21.1. 21.0. So Fg is equal to 21.0 kilonewton, and that's tension. And that was our last answer. So here we go. So to solve for all those members, we did a few free body diagrams, a few equations. You are free to use method of sections and method of joint in the same free body diagrams. If you do your project with stress, that's why I recommend to really go step by step and to find the right method and the right free diagram to solve for just one unknown at a time. So that will be easier to program instead of having a system of matrix, for example, to solve. And you're able to solve a huge truss if you go with the right path with just Excel, because it's just like simple equations where you solve for one unknown at a time, or you can use MATLAB. And I will show you how to do that if you do the project with a truss, depending on the semester. So that's it. That was your last problem for truss. Keep practicing any shape, any angles, any method, the one you are more that you're more used to use. But I would say sometimes the combinations of both method is great. Don't forget to look for zero force member if you can. That will be helpful. So congratulations. See you in the next chapter. Bye bye.